Today's show is sponsored by CloudZero. For software-driven companies focused on growing margins, CloudZero is the only cloud cost intelligence platform that puts engineering in control by connecting technical decisions to business results. By analyzing cloud services like AWS and Snowflake, CloudZero provides real-time cost insights that help you maximize margins. Engineering teams can answer critical questions like, who are my most expensive customers? How much does this specific feature cost our business? What's the cost impact of re-architecting this application? With cost anomaly alerts via Slack, product-specific data views, and granular engineering context that makes it easy to investigate any cost, CloudZero is your complete cloud cost intelligence platform, connecting the dots between high-level trends and individual line items. Join companies like Drift, Rapid7, and SeatGeek by visiting cloudzero.com/cloudcast to get started today. That's cloudzero.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Another Sunday show, not a Sunday perspective, but a Sunday show. And I'm going to kind of keep this intro fairly brief. We do have a very interesting topic this week. We're going to talk a little bit about how we manage data at the edge. We're going to talk a little bit about some of the database technologies, but also how we manage change at the edge, volume at the edge, kind of a topic that I know comes up a lot for folks that are looking at new applications at the edge and some things like that. So really interesting topic and guests coming up after the break. But first thing I want to kind of hit on, or the one thing I want to hit on here in the intro is, we're hitting a time in our industry which, and we've hit on this a few times in the past shows, the last couple of months, is, we're going through some challenges in the economy, or we're going through some times when maybe things aren't as high or valued, highly valued as they were, say, over the last few years, or actually over the last decade or so. And I know for a number of people that listen to the show, they're newer to the industry. There's some people that listen to the show that have been around for a long time in the industry, or listen to the show for a long time. One of the things I'm going to say is, whenever you start seeing some softening of the economy, or you start seeing some companies announcing layoffs, even if it's small amounts of layoffs, 10 people, 20 people, we may see some large numbers come along. We've seen some companies that have revised some plans, maybe not grown as aggressively. And I'm not trying to kind of signal a big red flag or try and create alarms or anything. But what I'm going to kind of throw out is, this is a really good time, if you can, to reach out to people reach out to friends in the industry, colleagues in the industry, mentors in the industry, for a couple of reasons. One, just see how they're doing. There's a lot of really good people in our industry that are always looking for good opportunities. You're looking for opportunities. Whenever, not that you shouldn't be sort of networking and keeping up with a good group of people all the time, but especially when things are starting to get a little bit tougher. If things are going well for you, reach out to some folks that may be at places that, may be struggling a little bit, just to check in on them, see how they're doing. If you, are concerned about where you are, reach out to some people that you know. There are still a lot of companies hiring. We're not in a situation in which things have kind of gotten flat. I know there's a ton of startups that are hiring. I know a bunch of people that are hiring. And I know that, there's situations that are, what'll happen is, groups will move resources around and people will reprioritize some things. So just be aware out there, talk to people, kind of keep your contacts open, be looking at what opportunities are out there, look at opportunities for you to learn some things, to double down on some things, to double down on your skills, even just doing basic things like updating your resume and making sure all the good buzzwords that recruiters and others are looking for are out there and prominent. So with that, I'm going to wrap up it's kind of the beginning here of our Sunday show. Like I said, we've got a really good, interesting one looking at, how we manage data at the edge, how we think about those types of applications at the edge, which are becoming more and more prevalent in our day-to-day life. So really excited to get to that after the break. Today's show is sponsored by Lightstep Incident Response, built on the ServiceNow platform used by over 6,000 companies worldwide. Lightstep Incident Response allows you to scale your incident response team without adding to your monthly bill. With intelligent on-call scheduling and escalations, you get the full context of your service health. Lightstep Incident Response immediately pinpoints issues and uses machine learning to send group text, reducing your time to respond. And you can seamlessly orchestrate alert and incident triage with on-call scheduling across Slack, Teams, Zoom, desktop, and mobile. So get started today with a free 30-day trial of Lightstep Incident Response by visiting lightstep.com/cloudcast. That's lightstep.com/cloudcast. And get a free t-shirt after your first alert or incident. Today's episode of the Cloudcast is sponsored by Datadog, a real-time monitoring platform that unifies metrics, traces, and logs into one tightly integrated platform. Datadog APM empowers developer teams to identify anomalies, resolve issues, and improve application performance. Begin collecting stack traces, visualizing them as flame graphs, organizing them into profile types such as CPU, I/O, and more. Teams can search for specific profiles, correlate them with distributed traces, and identify slow or underperforming code for analysis and optimization. Plus, with Datadog APM Live Search, you can perform searches across the full stream of ingested traces generated by your application over the last 15 minutes. Try Datadog APM free with a 14-day trial, and Datadog will send you a free t-shirt. Visit datadog.com/APM-cloudcast to get started. That's datadog.com/APM-cloudcast. And we're back. And, folks, we have at various points in time at the show, and if you've listened to the show for a while, we've covered Edge and IoT and sort of things around that space. And I find that as much as we as kind of an industry feel really comfortable when we talk about the word cloud and what public cloud means, Edge and IoT still feel like something that is very much evolving, very much, depending on the context of things, depending on the application, depending on the use case, can mean a lot of different things to a lot of different people. And so we tend to find ourselves coming back to this space over and over again because there is so much variation in what's out there. There are so many different things that people are doing. And, more importantly, the technology around this space evolves quite a bit. And so what we thought we would do is kind of, go back and explore both IoT, industrial IoT or IIoT, as well as kind of probably the most important thing when we talk about what goes on at the edge, which is data collection. How do we manage those things? And nobody better to help us do that than Brian Gilmore, who is Director of IoT and Emerging Technologies at InfluxData. Brian, welcome to the show. Great to have you on.
Yeah, thanks, Brian. Glad to be here. Appreciate the time.
Let's dive a little bit into your background. We always sort of like to get to know our guests a little bit before we dive into the technologies. Tell us a little bit about your background. Where have you focused on in the past, and then maybe more importantly, where do you focus these days in your role at InfluxData?
Yeah, sure. It's it's been a bit of a strange trip to get here. I actually started in music. I went to music school, but quickly learned I was in recording studios quite a bit, and quickly learned that my skills fixing computers were probably better than my skills playing the guitar. So that kind of got me into the computer business. I worked in a hospital. I built an integration with AS400 systems that we used for billing, and basically built some pivot charts and gave some of the practice leaders visibility into how the physicians were doing from a billing perspective, from a coding perspective, and said, wow, that was fun. But I moved over to the marine biology space, and I spent time in public aquariums, and while I was there I also built an application sort of as a side project to analyze data from the industrial control systems that powered the life support equipment that kept the fish alive in the tanks. And by the second or third time of building those types of systems and seeing the sort of value that people got from them, I was like, wow, maybe I could or should go turn this into a business. And so I joined a company in Atlanta. We started building smart building analytics platforms, and then I I connected with another vendor in Silicon Valley at the time, back in 2013, called Splunk, who was looking to build an IoT team in practice, and I helped them navigate that for 8 years, and sort of decided that I was going to, head back out into the world, and was lucky to run into InfluxData, and it's exciting. It's like this is what I've been preparing for the entire time. InfluxData's customers are so passionate, they're so informed, and what I like the best is the fact that they are using our technology to finally solve problems that they've been struggling with for over a decade. And the reason that feels really good for me is because I've been there with them for that entire decade. So it's exciting opportunity.
Yeah, no, it's a cool background for a couple of reasons. It's we're always interested in people who have come from sort of diverse backgrounds that didn't just start with I was a computer nerd when I was 9, and then I did computer science, and then you find that a lot of different disciplines help you think about things differently. You see the world in different ways, and then sometimes when they get applied to technology, to computers, it becomes a pretty interesting marriage of kind of ways of thinking about things. And maybe the other piece of it is you've been working on sort of IoT before it was called IoT and before it became cool, because we became sort of bored with what was going on in the central cloud. So good to see the backgrounds.
Yeah, it's funny that you say that, because that's true. I remember the first time somebody said IoT to me, and I was like, "Oh, great, we're giving the internet another name."
Right. So, exactly.
Yeah.
So, given that you've been, kind of living in this space for a while, and we're now in 2022, and how would you sort of explain that segment of the market to people? Because, like I said in the intro, it feels like, if I'm talking about industrial, it's one set of things, it's factory floors, it's, and if I'm talking about, talking to municipalities and they're trying to wire up, buildings or light posts or whatever, it's a different sort of thing. Like, how do you explain kind of the broader space where IoT and Edge kind of lives to people?
Yeah, sure. I mean, I think the place that you can most easily sort of pinpoint or point out IoT is really sort of at that cyber and physical divide, right? So like where technology interacts or interfaces with the real world, as I like to say. And I think this is sort of contained within a whole bunch of other sort of technology megatrends like augmented reality and even like gaming and, all sorts of different, consumer technology products. Our TVs are smart now, our refrigerators are smart, everything's smart. But I think the real difference has been, at least in the last couple of years, is that people are finally becoming comfortable, not just with the fact that the technology is available, and even that the technology works, but they now are starting to understand like exactly what the value to the business is in terms of investing in these types of technologies, right? Because, I mean, people have invested in technology for technology's sake probably since the dawn of technology. But,
sure.
I think getting to sort of really understand like, why are we implementing this tech? What are we going to do with it? Whose problems is it going to solve? And how quickly will it solve it? Has been key to like getting the right stakeholders around the table to actually do these things successfully. And I think, to your point, it's like, the data is one thing, the sensors are another thing, but ultimately all of that just feeds towards some type of like quantifiable business outcome. And I think that's been the major difference that we've seen, at least over the last like 3 to 5 years.
Yeah. We've said for a while that, if you're really into hardware stuff, like the sensor piece might be interesting. To us, it's not super interesting. It evolves over time. They get denser, they get smaller, they get faster. But the data's always been really, really interesting, because it's, when we start talking about stuff at the edge, you're not just sort of collecting mass volumes of data. You're not necessarily, applying teams of data scientists. It's sort of, there's a lot of variation to it, whether it's, how quickly you're trying to capture something and make a decision, thinking about stuff like, how long do I keep data out at the edge, or do I bring it back into something centralized? Like, how do you find, companies? Because like you said, ultimately the data is a piece of the puzzle that hopefully, solves a business need, gives better business insight or, government insight or whatever it might be. Like, how do you find people think about the data? Is there a way that they, is there sort of a smart way they go about thinking about it? Or are there common mistakes that people make when they think about edge data per se?
Yeah, I mean, I think the most common problem is kind of thinking about IoT and maybe the technology that's part of that stack as the thing, right? It is just sort of a means to a solution, and it runs almost always alongside of a whole, sort of bunch of other technologies like cloud, like AI, like ML. There's almost always Kafka and MQTT in there these days. So like, it's you got to think of it very much as sort of like what is the primary purpose of the applications and the technologies that are deployed as part of this. And that's very different on the manufacturing floor. You might be, working with like equipment pallets, or you might be working with PLCs and other sort of traditional automation tools. And those technologies are out there to do something like make a widget or, drill for oil. And what you're really trying to think about in terms of using the data is how do you instrument that primary technology or that primary process in a way that you can sort of be sure that the technology is doing that you've deployed, whether it's automation and controls or autonomy, whatever it might be. How do you make sure that it's doing its job? How do you make sure that it is functioning properly? How do you make sure that it's secure and it's reliable and it's safe for the people operating around the equipment? And those are the types of, I think, fundamental use cases or challenges that people then start to think about. How do we collect data related to those issues and actually pull that up to a place where it can be used, right? So like, your maintenance teams may be more interested in like optimizing, equipment overhauls, right? So they'll want to collect data related to that. And oftentimes that doesn't require resensoring. I mean, that data was collected already for automation and controls, whereas your business people might want to use, similar or related data to, optimize the supply chain or predict, future demand on whatever the resources you're producing. And the difference between success and payoff and like pilot purgatory has really been that sort of like focus on the use cases and the problems, and then being very sort of precise about the data that you collect and, process at the edge, process in the cloud, or process somewhere in between, because it's, it's not cheap and it's not easy to do it at the types of scale that these folks are wanting to do. So,
Yeah, no, it's interesting. I find that like the types of problems people try and solve at the edge can be, huge in scope. And yet sometimes we get wrapped around the idea of like, oh, how big is the thing? Like, is the device, like we think about edge, as this sort of small thing. And for a lot of companies, what happens at the edge of their business is, the majority of what they do. So yeah, it's interesting to sort of hear the mindset that you have to really be successful with it.
Yeah. It's literally where the rubber meets the road, right?
Yeah, absolutely. Yeah, I mean, you think about, whether you think about retail or you think about logistics and deliveries or, all sorts of things, airlines or whatever. I want to talk a little about the technology. Obviously, Influx is incredibly well known for InfluxDB time series database. I feel like, there's lots of places for lots of different databases within applications. Within time series feels like sort of the perfect database for at least a lot of IoT and IIoT types of use cases, because it can be somewhat real time, but it's designed to be around kind of historical things that you can kind of reason over. Is that a good way to think about things? Are there kind of unique characteristics that Influx is doing to make InfluxDB kind of more geared towards IoT and IIoT?
Yeah, for sure. I mean, I think first to your main point, I think having a database where the timestamp, especially as we supported timestamps down to like nanosecond precision, is those are supported in our platform as sort of like the primary key, right?
Yeah.
And what we do is we use those timestamps and other features of the data to actually create series of events or metrics that can be processed, recalled in ways that are sort of time-centered, right? So you might want to be looking at, like, what is the latest reading, right? That's a single sort of real-time value versus what is, the min and the max, the average over the last minute or the last day, or, in the last time that, that outside air temperature was the same as what it is now, right? And to be able to, like, quickly query massive volumes of data using time as the first sort of, constraint is difficult to do. I think, like, you can see there's a number of other companies, solution services out there that have taken all types of things like, Postgres or Cassandra or Node or Node DB or whatever it is to sort of like put together a time series database, but like ours fundamentally from the ground up was built for sort of that time being that primary sort of component. But we weren't the first to do that. Like you can look back to even the 80s where you sort of had the emergence of process historians and things like that. Those legacy systems are still out there. They're still humming. The thing that I feel like we did differently is we sort of reinvented it or modernized it in a way that, every company now has like really tech savvy. They may not be developers or engineers per se, but they're folks who are good enough with computers and applications to actually build some stuff. And, we took an API sort of first approach to the time series database where, we have a UI for the folks who want it, but for those developers who just want to hack something together quickly to get data from asset A to system B or to put it in front of a particular set of stakeholders, we make that really, really easy and really fast. And we do it in a way that like makes sense for those industrial IoT or IoT practitioners because of the way we sort of support very precise, very granular data collection, maybe short-term storage at the edge, and then can seamlessly allow them to manage that by downsampling or anomaly detection, aggregation in the cloud, where they could apply all of that cloud goodness in terms of horsepower, whether it's from machine learning or UI or just having a centralized API where mobile apps can call in, et cetera. And that is very different than what's been out there in the market, either in sort of the legacy software or even with some of our competition in the more modern, time series databases. So.
Yeah, no, it's interesting, especially if you've ever been on a shop floor of any sort. I mean, there's, tons and tons of super old, Windows, VB types of applications, lots of UI, ugly UIs. And it's interesting that you're now highlighting that, yeah, the product has an API, has a UI, but really, it's driven through APIs and which, has become very much the modern thing, but we don't always think of shop floors as necessarily being modern environments. It's good to hear that's the case.
Yeah. I think it's a bit of a stereotype, to be honest. And I think it's been changing pretty consistently over the last 5 to 10 years. I think, it's easy to think about the shop floor as sort of Cro-Magnon technology, but it's not really. It's, these folks are extremely savvy. A lot of them have engineering degrees. And sort of as the new generation is coming in, they are coming in very, very tech savvy. These are digital natives who are being hired by these companies. I think if you look at one of our customers, Tesla, there's been some awesome coverage recently on their use of all kinds of technology to create virtual power plants. First in California, and now they've started rolling one out in Texas. And those types of folks who are building those types of solutions, like, hey, we already have power walls and solar arrays in homes, why don't we create an opt-in where we can tie this all together and then work with the power companies to actually use that storage and that production as part of the power plant, we were just another sort of cogen facility. They're able to implement that and execute that extremely quickly and extremely effectively with a product like InfluxDB, because all they have to do is they just have to work our APIs into whatever the existing design blueprint is that they have. So, and we're seeing that everywhere. We're seeing it in manufacturing. We're doing some really fun, cool work with Schubert Phillips at the Heineken plants with AWS. And it's just, there's smart people out there who are building really cool stuff with these more modern technology stacks. And it's been really exciting for us to sort of get to ride along.
Yeah. Yeah. I want to touch on a slightly different piece of this. As we talk about data and we talk about edge data, what are the best practices? Obviously you guys are, have deep expertise in collecting data and managing data, but what is, how do companies think about data at the edge in terms of, how much to collect? Because obviously sometimes you're restricted by how many resources are out there and how long do you retain it? Do you bring it back to a central location? Are there kind of best practices? Does it really depend on the use case? Obviously a lot of times some of those remote locations don't have necessarily, the the robustness of internet access or, speed? Like what do those edge best practices look like, especially for data these days?
Yeah. So, I mean, I think the data is a kind of a loaded term in a way. And I think like when people talk about, oh, there's like, gigabytes of data generated per second on X type of airplane or whatever, they're not only talking about like time series textual information like metrics and events, right? Like oftentimes that's like full-blown analog recordings of audio and video. There's tons of like very massive data that's sort of out of the scope of what we or our customers would be concerned with, first of all. I mean, when you think about like a metric, right? Like it's got a timestamp, it's got, a sensor name, it has a value, and maybe a couple like metadata fields, that are going to make that piece of information easy to put in context. I mean, that could be like 150 bytes for one event, right? And so it takes a lot of those events to start to do things like overwhelm the networks or the disk drives and things like that of, anything that's been built in the last 10 years. So what I try to do is I try to talk to customers about like, let's just focus down on that sort of instrumentation of the applications, the technology, the sensors, the processes, the automation, all of that, and see what we can do to collect that data in as sort of granular and precise a way as possible. Because what I like to tell customers is like, if you think back to like television in the 1950s, right? It was probably like 10 pixels by 10 pixels. Everything looked 8-bit to me. But it was like, and I wasn't there in the 50s, by the way, this is just me sort of going off. It's like that low definition view was there because it was really hard to transmit that kind of detail over the existing networks. But like modern technology in that side of things has progressed to the point where we're sending like 4K over the internet, stuff like that. And the 4K gives us a much better picture of whatever it is that we're observing, right? And that applies to them in terms of their operation. So the more sensors you collect and the less time there is between sort of reading, the higher definition the picture is you have of your operations. And yeah, you might not feel like you need all of that precision now. Like I can look at a 480p picture and say, yeah, that's a baseball game, right? But when you put that type of information at that really high, really granular sort of perspective in front of your domain experts, they will see things and they will recognize things that others won't because they have a clearer picture. Now, doing that all the way from the edge to the cloud is just completely impractical. And we understand that. So what we've done is we just launched a new capability called Edge Data Replication. So we have commercial versions of our software that run in cloud. There's also a free version that runs in cloud as well. But there's like 600,000 instances of our open source database out there running in community, customer, partners, data centers, or even all the way down to the edge. And so what we've done is we've added in 2.2, the new release of our open sources, we've added something called Edge Data Replication. We're keeping it short to EDR. What that does is that allows a customer to collect and store in as granular a way as they want the data at the edge. So for example, you could say like my disk will support 1,000 events per second across 1,000 sensors, and it will support that for a period of one day. Now, you could just put another database right next to it, another open source database right next to it, just go across, and you're just literally horizontally scaling to increase that. Now what you can do is through like literally 2 API endpoints, you can configure those edge databases to like summarize, analyze, detect anomalies, detect notable events, things that you would want to sort of keep for longer periods of time, and move those into a sort of second database there on the edge, or we call it a bucket, which is sort of the main holding for the data. And what EDR does is now it says you can configure any bucket in an open source instance at the edge to replicate in real time to the cloud. So people are getting smart and they're saying, okay, cool. Well, I have one bucket that's got my really precise data for my operators working in the plant or for like feedback into the automation control systems. But then I'm using these Flux sort of scripts. Flux is our time series processing language to identify data that needs to be stored for longer periods of time or needs to be looked at by different stakeholders. I move that to a bucket that's configured for replication. And then with a disk-backed queue and sort of durable replication, like you were talking about, it will monitor for available network between that edge InfluxDB instance and a cloud InfluxDB instance. And it will replicate that data through in as near a real time as the network will allow. So you now have like this best of both worlds, high precision, high granularity, time series analytics at the edge where, that's where the data is born. Data has, it's born somewhere, point of origin. It has a half-life in that the older it is, the less valuable it becomes by its nature. But it also has gravity, right? So this allows you to actually take that data with the highest gravity and move it someplace like the cloud where all of those other powerful applications like talked about machine learning and mobile integrations, all that kind of stuff can work with the data as well. And it's cool because we have a single unified API that works across all of that. So now customers can build once, and like you could have a mobile app that through smart proxying or whatever could, when the end user is on the factory floor, he's working with the local highly granular data, but when he's checking in on something from home, he's working with the data that's been summarized, aggregated, and put in the cloud. And that's like a brand new offering, and it's like people are just eating it up because it solves a big problem of sort of like, what does the data orchestration and the pipelining look like for these types of IoT use cases?
Yeah, no, good. Lots and lots of good stuff there. Let me ask you one last question because we've this has been really, really fascinating. Kind of digging into all of it. Our audience loves to sort of be thinking about what might be coming next. What sort of trends are on your radar? Things that are fairly new, or you're starting to see sort of pop up just around Edge that maybe haven't gotten a lot of spotlight, but you expect to be starting to pop up on people's radars and headlines and other places fairly soon.
Yeah, I mean, I think a lot of work is being done around machine learning. I think like if you look at like all of the micro X or Y that was been built, for TensorFlow and for Python scientific computing, like that was, up until probably about a year ago, that was really about just doing some of what you could do in the cloud with machine learning at the edge. But now what you're seeing much more sort of true hybrid machine learning practices where, data is being generated at the edge. It's being, fed through these machine learning processes. It's being clustered. It's being aggregated. It's doing whatever that needs to happen there at the edge. But then also data from like you said before, it's like the edge itself might be small, but in aggregate, it might be tens of thousands of assets all doing one thing, working together as a group or working independently. And so like having all of those edge instances report back to the cloud in terms of the effectiveness of those machine learning processes, as well as like sending more additional training data, anomalies, things like that, so that those machine learning algorithms and the models can be like refined in the cloud and then passed back down to the edge asset. That's what's going to enable like all kinds of autonomy. And that's what we're seeing, like to your point, in these sort of like really advanced use cases like space, right? Satellites, Web3, all the sort of crypto use cases. These are all highly decentralized, highly distributed technologies. And these types of data interactions are going to need to, be available to the folks who are building like what comes next in those fields.
Very cool. Very cool. Brian Gilmore, thank you so much for all the insights today. Like I said, we hadn't touched in this space in a little while, and you sort of blew the roof off with a ton of really good information for us. Real quick, if folks want to, either pick your brain about these things or, kind of dig into, what InfluxData is doing around these things, what are some good places to either reach out to you or, engage with your team and so forth?
Sure. Yeah. I mean, you can find me personally directly on LinkedIn. It's just pretty easy, Brian Gilmore, and InfluxData. But then, of course, we have got a great website, InfluxData.com. Folks should check out our GitHub as well. Like I said, we're an open source first company. So, we got like 23,000 stars. It's not difficult to find us out there, but, it's a great place to start. And then, we're on Slack. We've got a great sort of community going on Slack with lots of questions, lots of people. It's just called InfluxDB Community. So just check us out there, ask questions. If I'm there, I'll hop in. And if anybody wants to reach out directly, feel free as well.
Very cool. Very cool. We'll get some of that stuff in the show notes as well for folks. And well, Brian, thank you again for the time. Aaron and I both really, really appreciate it. And folks, with that, we're going to wrap it up. We are going to, thank you so much for listening. Thanks for giving us the feedback. That we've gotten a lot of really good feedback lately. And thanks for telling a friend. The show continues to grow throughout the first half of 2022, and we really appreciate it. So with that, we're going to wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.